There's already one question about circularity. I will also discuss this a little bit today, but the circularity score can decrease based on, for example, the type of materials you have used there. So even though you might have reduced the emission levels, it could be possible that you have used some materials which had a lower percentage of recycled content or anything like this, which then, of course, directly influences the circularity score. But we'll talk a bit about optimization from circularity point of view today as well. I think we can start now. The session is, of course, it will be recorded, so you can check it back later. Maybe one of the panelists can already share the link for this slide as well. It's been uploaded already on the resource hub. So if you guys have checked, these slides are available there already. So let's get started. Welcome to the 6th session of the One Click LCA Summer School. Let me just see if I can select my right screen so I can actually move it, and I can like this. So just like all the other sessions, please just remember to use the Q&A section for the questions. I am joined again by our very talented moderators, Samantha, Antti, Rosa, and Sean, who will be answering any questions you might have throughout the session. I intend to do it kind of the same. We'll talk for about 1.5 hours. I'll discuss some theory and I'll discuss some parts about the software itself. And then we have about 30 minutes of Q&A time as before. Samantha has just linked in the chat the resource hub, so the slides for this session are already available, so you can check them already if you want. And the recording will be available tomorrow morning, like previously. So the last session was on Friday. It was done by our CEO Panu Passanen, and he discussed a lot of different types of construction materials, or at least the ones which cause most of the emissions, and gave you a bit more theoretical insight on which materials are there and how you can find some of these in the One Click LCA database. So I really liked the session there, so I hope you have all enjoyed it as well. Remember, if you want to join the user group, just go to LinkedIn, just search for LCA Made Easy, and you can discuss anything you want regarding LCA, specifically regarding One Click LCA, of course. You can do that there very nicely. So one thing that I kind of have to mention, I'm pretty sure that most of the people who are joining this course are familiar with these kind of things. But of course, this morning, the new IPCC report came out, which basically kind of stated that the world is warming much faster than we want to, and that we really have to do something about this. The direct link you can also check later. Of course, this is quite important report for anybody in the world. But specifically what we can do about this is, of course, the majority of emissions for the construction realm, 39% globally, those are the ones we can actually influence. So it will get worse probably before it gets better, but we know what we have to change. There was also this kind of regional fact sheets, which are available to all of the regions. The link one to Europe is here as well, which basically tells what will happen when the current global warming will continue to rise. So we'll have more heats, we'll have more extreme heats and extreme colds, extreme dries, etc. So it's not looking too great, unfortunately. If you're interested in this, definitely take a look at this report. It has a lot of very important information. So as I saw earlier, or as I said earlier, 39% of global emissions are coming from the construction industry, relating buildings, of course, 28% from operational emissions, and 11% from the materials and the construction. So those are the kind of target groups we are trying to reduce. I can already see there's some questions about the sessions of email. They will be available for a while. I'm not really sure until what time yet, but they will be available long enough. And we're actually also extending the license that you have in the software until the end of the month. So if you want to play around with One Click LCA a bit more after the summer school, you can do that as well. I'll go to the next slide. So today I'll be discussing, first of all, Carbon Designer. So Carbon Designer is our early phase concept tool, which allows you to get already an estimate of your emissions from very basic information. So if we have just maybe our building area, we know what building type we're going to be doing, let's say an office building, and we kind of know the frame concrete, then we can already have an estimation of what the emissions will be for a building of this size. So we'll discuss those. I'll discuss then optimizing these kind of baseline results. And we can do this from two different ways, or we will do this from two different ways. From an emission point of view, so we'll look how can we actually reduce the emissions if we're doing different options or these kind of things. And then also from a circularity point of view. So we'll actually take a look at how changing emissions changes also the results from circularity point of view. We'll then talk a bit more specific about materials, so construction materials in our database. I will discuss the structure of the material groups we have. So how do we classify the materials in the software? How do you find them? And then we'll also discuss how you can compare them with each other using two of the features in our software. One of them being the advanced material comparison and the other one being the green materials benchmarks. Then we'll cover a bit about the results. So we can have results for calculations from the main page, but also from the results page. So we'll discuss what the differences between these are, what you can get there and whatnot. And then we'll have the Q&A part. This session today doesn't have homework, but if you guys have some questions specifically about the homework of the previous sessions, maybe we can discuss that a bit more in depth today as well. So when we are creating a Carbon Designer project, you can do this in a new project, or you can just create a new design. You basically just fill in the initial project setup. So perhaps we tell what kind of project it is, where it is located, and then we can just go to input data as we see here, and we just click on create baseline. So the creating of the baseline is always the initial thing of the Carbon Designer setup. The setup I have chosen for this example, and you're of course welcome to do anything yourself as well. It's kind of the same setup we have also been discussing before. For example, that article about the 10 commandments. If we're setting the project up first, we have to decide on our material scope. So what kind of data do we already want to include here based on the limited data we have? So as you can see here for the example, we have set up this with the foundations, the substructure, the ground slabs, the structure, the enclosure, and the finishes. You can also include the services, but the services module we have currently is still in a beta. So basically you get some kind of estimations for the material emissions for HVAC or heating and cooling and these kind of things. But it's also important that we select the right reference building. So to some of you, there might be other type of reference buildings available if you're perhaps in the Nordics or if you're in the UK, which are more relevant than the international version. But if you're not in any of those regions, just pick the international one, and this will be somewhat the best option there. The building type also very much depends, because the structure of the materials and the quantity of the materials within the different groups in the building, of course, are going to be different depending on the different building type. When we are selecting a building type here and you're not really sure where your building belongs to, if you don't want to do an office, but perhaps you want to do, let's say, a fire station or something, just take the building type which would closest match that. Now for a fire station, this could be, for example, an industrial production hall or something like that. We then have the gross floor area. And in this example, I have chosen 7,000 square meters. For this example, I have 7 above ground floors. We have a calculation period of 60 years, which you can of course change if you know it's better or different in your area. Then we have the underground floors. And in this case, I've chosen for 2 underground parking floors, which are not heated. I have not chosen an earthquake structure, but if you're in an area where you have seismic activity, you can of course do that. I have chosen in this case a steel core piling foundation for hard soils, 50-meter depth. This kind of links back into those design commandments which said that you should only build on good soil, because of course otherwise it can take you quite a lot of extra emissions for the materials you have to put in the ground. So take that into account as well. And then we can select also a scenario. So the scenario I have chosen here is a precast concrete frame, but you're welcome, of course, to also do something else. So you could even already fill in a comparison scenario where you perhaps compare it against steel or anything like this. So if we have the setup right now, I'll go to the next slide. After you have filled in your project parameters, you'll go to the building dimensions. So based on the parameters we have set up, I have gotten some dimensions for my office building. So it will, for example, be 25.2 meters high, 47.5 meters width. There is a depth, internal floor height, so the space between the 2 floors, and also if there is any load-bearing internal walls, the amount of staircase, etc., etc. The only thing you shouldn't really change here is the shape efficiency factor. So the shape efficiency factor has been decided a long time ago when we have created Carbon Designer with the Norwegian real estate agency. to basically ensure that all the buildings you're making are not exact shoe boxes. So that is something we should change. Not change, I mean. All of the other parameters you can change. If you make some changes to the parameters in green, it will also automatically update the building structures, but it doesn't go the other way around. So if we, for example, say, okay, we have the height of 25 meters. If I change the foundation to 8,000 square meters, it won't automatically update the building dimensions. So just make sure it goes one way. I'll also show this in a bit in a demo. I'm just covering first the theoretical part of this, and then I'll actually show how this works. So if we go then to the next one, and I'm sorry about my mouse, I just try to navigate between the screens. We can then also make some changes. So after we have decided on our building dimensions, we get to the overview page where we already get that overview. So we have here our baseline CO2 equivalent per square meter. I can also click on the assumptions if I kind of want to go back to what I've just done before. So if I want to see what I filled in for how big my building is or what kind of frame I have. The emissions you see right now are the chosen design I had chosen. So this was a precast concrete frame. If I would want to, I could change it right away by going to this apply scenario and taking a new option. The apply scenario is not available in all versions of Carbon Designer, but in most of them, for example, the international one, you have it as an option there. We can then also go through all of the different elements here. So we can just click on these elements, expand them, and see what is basically underneath them. So if we have the example here, a concrete column, I can already see that there is some data underneath it, but I could actually also click it and choose something else. If I would want to change this to a steel column or perhaps wood or any other option, it's possible. And most of these options, you can also change the constituents underneath them, which I'll show in a bit, but you can do that by clicking on the edit button. So if you click on the edit button in the concrete, I could, for example, change the grade of concrete. I could change it to have a different percentage of recycled content, or I could change the reinforcement steel, these kind of things. So all the elements which are related to the constituents, basically. If we then save this, it actually moves it directly to our building materials query. So we then right away have the data there with the different constructions. So I'll cover this also in a bit, but we then have, for example, the steel core piling, which is automatically calculated, it already has constituents behind it, the concrete sandwich elements, etc. If we then actually want to get the results, the only thing we just have to do is make sure that the mandatory queries are filled in. And that is pretty much it for that. If we fill in the mandatory queries, we actually also get our results. So this is what I'll show in a bit as well. So then if you have filled in your Carbon Designer, you can right away get the score in kilograms CO2 equivalent, the total number, and then also right away the circularity score just based on the materials we have included right there. So now I'll talk you basically through how we optimize this and make sure we can make some changes here. And we'll do this in this case from an emission point of view and a circularity point of view. So I'll now switch my PowerPoint away and we'll go through these steps in the software. So I'll open my project, section 6 Carbon Designer demo. And as you can see, we already have done some stuff here. So let's run first once through the step of actually creating this Carbon Designer design. And then we'll do again this optimization. So for this, I'll just create a new design. So we'll just do example Carbon Designer setup. I'll just leave everything the same regarding the settings. I've set up this project to be in Finland, but you can of course set it up for wherever you are. We just click on the input data and we just go directly to the create baseline. So what we have just saw before. We have then the building parameters as we see them. We can have the different reference buildings. So in this case, if you're not in any of the regions you see here, I would just pick the international reference building. We select our different building types. So for this one, I select the office building. We select the parameters. So we have the gross floor area of 7,000 square meters. I had set mine to 7 floors and I set mine to a calculation period of 60 years. I then said that I would have 2 unheated parking garages. I'm not in an earthquake zone, so I don't have to change or reinforce the structure, but I do have to fill in the foundation. I think I'd selected it was hard soil is 15 meters. We can then select the baseline scenario. So I could right away say, okay, we're going to take the precast concrete, but I could also apply a comparison scenario if I would want to. So for this example, I won't do that. I'll just click on the calculate areas and see what we get. We then have our building dimensions. So we have the different elements of how long everything is. You can also open the more parameters to see a bit more what is underneath them. And then based on the parameters or the dimensions we have here, it automatically creates our building structures. The building structures are important because they define actually the quantities of our materials. Because if we use Carbon Designer, it makes use of our construction. So basically these ready-made assemblies, which already have materials underneath them. So there's an assembly for the foundation, for the cleanliness layer, for the ground slabs, etc. So all that is already available there. If this all looks okay, I'll just click on Create Baseline. And in this case, it will probably take about 10 to 15 seconds. But now it will try to make my theoretical building that I've inputted there based on those settings. So now it's creating an office building in Finland, 7,000 square meters, 7 above ground floors of 1,000 square meters each, 60-year life period, 2 underground floors, and I think I'd set a 15-meter foundation depth. So I'll just have to wait until it bundles this together. Sure, Maria. I'll try to talk a bit slower. So now we can see what it has created from Carbon Designer. So I'll zoom in a little bit. We can see we have gotten our emissions for our baseline CO2 equivalent. Yeah, I'll zoom in a bit more. Is this better? We have the assumptions here. So in the assumptions, I can right away see what I have chosen already. If I want to go back to there, basically what I've just discussed. So that 60-year life period, 7,000 square meters, 7 above ground floors. If I then have the initial choices, I could make a new choice. So I could, for example, load the entire building to have a wooden structure, or I could do in situ structure or steel, and it would automatically update everything. But you can also do that manually. And the manual part is the part where I kind of want to discuss right now. So if I have these elements, maybe we look at the ground slabs. I can see that the ground slab is a concrete ground slab assembly with some insulation. And if I open it, I can also see the elements underneath them. So we can see that there is, for example, EPS. I could also choose different type of EPS or have different type of concretes I could choose, different type of reinforcement, etc. If I make some changes here, it will automatically update it. So if we have here 126 tons of emissions for this specific assembly, I could say we're changing this to reinforcement steel 100% recycled, and it changed that by about 5 tons. So we can right away see also it updates, optimized 121 tons. We can also change entire assemblies. Of course, from an optimization point of view, it's really nice. But if you're having a building and you're only changing the columns to something, it might not be structurally sound. So you have to make these kind of changes that they would, of course, be representative. But let's say we have our concrete columns. We can see from the concrete columns that these are made with a ready-mix concrete and with a reinforcement steel. I could also click on these to find out information about them. But what if I change these concrete columns to steel? Like we're not doing any concrete columns now, we're tracing it completely. We change here to steel column. It will update it, making sure it has changed them. And then right away, we can see that if we're actually making this change, it's not really for the better. We're actually ending up 4% higher emissions. But if we're changing this to a timber concrete or timber column, my bad, we can see that we actually reduce the amount of emissions there. So this kind of quick optimization you can really easily do in Carbon Designer. You can also do it later when you're on a building material query, but if you want to maybe already try some different things, we can do it here as well. So for most of these elements in the building, we can do this kind of optimization. Not all have these options, like balconies, we have just a couple options, but for example, staircases, there's just one option. Because usually if we're having an office building, staircases are still using a concrete elevator shaft, which while you could replace it with CLT, it's not a very common option nowadays still. So you can go through all the options to make sure that what we have chosen is relevant for the type of assembly we are doing. Maybe I could, for example, change my roof to a green roof assembly. And I just wait until it uploads. And then I can right away see that for the roof slabs, for example, I've done some optimization now as well. So these kind of optimizations you can always run through and find out what would work best for you. If this works okay, we could set, okay, we are making this our new baseline. So these options are now going to be our base, and we're going to try to improve that on that again. Or we could also save it directly to our building materials query and just see what kind of results we get right there. So if you click on the save design, it moves it right away there. And in this case, it will actually move it first to the building material query, not to the result page. There's one question, is it possible to see the layers within a certain component assembly? Yes, and I will show it in a second once it's done loading this. Usually it takes, again, about 10 to 15 seconds, and then it will be ready for usage. So we can see, instead of, if you normally do an upload, it takes you straight to the result page. Here it will take us first to the building materials query. And to answer Zahabia's question, can we see the layers? So the different type of constructions we have used, they are usually defined based on square meters. So we can easily calculate with Carbon Designer when we have very basic building parameters available. If we, for example, take the steel core piling, this specific one has been recorded per square meter. It also says so in, for example, the resource names or the description. And it then automatically has the data per square meter. So if we would want to quickly change this to, let's say, 1200 square meters, they automatically update the constituents as well. And these type of constructions is basically how we do all the Carbon Designers. So it doesn't really matter what version you use. They usually have very custom constructions which are relevant for those specific areas. If we're, for example, loading this Carbon Designer in Southern Europe or in the UK, the different type of constructions there will be different, and the different constituents will be different. The quantities of materials will be different. So they're all adjusted to what we are basically commonly using in those areas. These kind of constructions, as I said earlier in perhaps session 2 or 3, you can also find yourself by going to the material filter and actually searching for the constructions there. So there's a lot of these ready-made constructions. If you're not really sure about what kind of materials would be included, you can find them there and go through them quite easily. So how would we do this kind of optimization? Well, we can already do it in Carbon Designer. Basically, before we actually end up on this phase, we decide, okay, we want to change the ground slabs or we want to change the external walls. We could already make the change there. But if that point maybe wasn't the best point, we want to change it later, we can still do it also here. Let me just upload one more panelist. Give me 1 second. Promote it. So I will go back to the main page. I'll just quickly enter an energy consumption, so we actually also have the figure for this design. And then we can talk about how we can actually optimize the design from an emission point of view to reduce emissions, but also from a circularity point of view. So I won't actually enter a quantity of energy. I'll just give a base value or a 0, so it actually loads the number. And once this is loaded, I'll take us back to the main page for a sec. Okay, it has loaded that. So if I now go back to the main page, this design, my example setup has been kind of mixed with what I have there. But as you can see, I'd already made 2 before as well. So the first design which I had made was the office building, where I actually did the concrete, precast concrete frame. I have already done one iteration, which is a wooden frame. So completely timber, as we can see, much lower in emissions. And now I just made some changes in this example design. So making these changes can be done quite easily. So you can, of course, make new iterations of Carbon Designer, or we can do it completely manually. But one way to do it really quickly would be to first of all make a copy of an existing design. If I have the concrete office here, which I've already done, I can actually go open it and it tells me I can optimize the design. If I would optimize this design right here, it of course would change all my material quantities. So if I would want to use this as a baseline to start with, I probably don't want to change it. So maybe I want to make a copy of it instead. If I would copy this one, I'll just go to copy design. Maybe I want to make this my steel option. So I could just say steel office 7,000 square meters. It will create a new design with exactly the same data in it. So in that case, the copy design still has a concrete frame, but we can change that quite easily. So we have now the steel office, which is the same. If I then go into here and I go to optimize design, I'm only optimizing this specific option. So now it will open my copied concrete design where I can make some changes, apply some different settings, and then I could quite easily already do a comparison as well. Just waiting until it's done. Maybe I can answer one question in the meanwhile. Harry Fry asks if we do a more detailed design after Carbon Designer, is Carbon Designer updated with the new volumes and materials? So if you add materials after you have done it, it will not update those automatically. So Carbon Designer really works with these presets with existing constructions. If we change those existing constructions, it works. It will change them automatically. But if you add any new data, it will be kind of like an, how do you say, an extra or optimized assignment. It doesn't stay within the same design. So I have now still the same baseline CO2 equivalent as I had in the beginning. No changes because, of course, I haven't made any changes. So if I would now apply a steel frame, it will warn me right away. If I make this change, it will change all the materials I have here. So if I would have actually added manually some new data here, that would be overwritten. So very important to take note of that. I'll just automatically let it override because I don't have any need to keep this copy design the way it is because I already have the original one, which was concrete. I can now see that from the changes I have made, we have changed it from a precast concrete to a steel structure. All the emissions we have will now be relevant for a building which is steel. So we can see we have some hollow core floor slabs. We still have concrete ground slabs, but if we check the columns, these are now steel, and the beams, for example, are also steel. So all the structural elements of this entire building are now steel based. On the overall, comparing them with each other, we can see that it doesn't have so much effect on the foundation or the ground slabs, because in this case would be concrete. But the columns, the change is quite significant. For the beams, the change is also quite significant. So we need much more steel to have this building be structurally sound. But if we take a look at the external walls, we actually reduce the emissions there. And we can also see that the roof slabs are also lower. So if I would just save this directly to the building material query, there's a comment from Palab that the instructions shown may not be that practical right now because the real life choices are made on discussion with structural engineers. Of course, that is true. But Carbon Designer is intended as an early phase baseline tool. So when you just know what size building you're going to be building, you might know the floors and whatnot. You could already get an idea of what the emissions would be. If you're in much later phases design, maybe already in the concept design or whatnot, probably you won't look, or detailed design, you're not looking at Carbon Designer anymore. But before that, if you don't have so much data, you might not have a BIM model, you might not have cost plans and whatnot. For that part, it's a great tool. So I will go back to the main page, and now we can actually see right away also how we can compare these with each other. We have now our concrete office. with a certain value, 2.3 million CO2 equivalent, give or take. Our wooden office, kind of lower, 1.6 million, a little bit higher also from circularity point of view. And then we have our steel office. So these materials or these designs I've created all have a different type of material setup, but they're all representative for an office building of the same size. If I would also compare the designs underneath here, I could, for example, see right away that global warming potential wise, the wooden building would be much better. If I would check the different life cycle stages, I also just have lower A1 to A3 material emissions. So it's quite good. But if we take a look at the other emissions, for example, the replacements, kind of the same. There's a bit lower replacements if we do a steel building versus the rest. We still have kind of equivalent end of life emissions. And of course, we have some construction emissions, which are kind of same, and transportation also not that much different. If you want to change, also looking at different type of indicators, we can do that as well. So right now we're looking at the global warming potential, but if I perhaps want to approach this from like a biogenic point of view, so what is much better to use, we can see, of course, that the wooden building has much more organic materials. So technically, we could have much more benefits from there at the end of life as well. But we can also look at any of these other indicators. So we could do ozone depletion potential. And from an ozone depletion potential, we can see that steel building is most intensive and wooden building would be lowest. But if I want to do this from a circularity point of view, I just want to get the total circularity scores, I can do that as well. So we can now see the different materials here, what the circularity score is. So if we're doing this kind of optimization from an environmental point of view, we can see that if we lower the emissions by quite a lot, in this case, almost 700,000, it doesn't necessarily have to change the circularity point of view right away either. So we can see that our concrete building, where we had a 28% circularity score, but 2.3 million emissions. If we do an office building, wooden office building, the circularity score isn't necessarily that higher. And that, of course, has a lot to do with what kind of materials we are sourcing for the project. Maybe let's take a look first at the concrete office. So I'll open my settings there. I have all those different constituents, so we can see why the score is the way it is. If we're opening this one, we can see that, for example, for the steel core piling, we have used, in this case, steel profiles, which consist of 60% recycled content. That, of course, directly translates to our circularity point of view that there's 60% recycled steel there. If we're looking at the concrete, we have used an option with only 10% recycled binders. But recycled binders in concrete are not equivalent to the amount of, for example, cement there weight-wise. So 10% recycled binders in concrete means only 1% recycled volume of our materials. And when we talk about circularity, we of course look at all the materials in our building, not just some parts. When we also look at the different elements here, we can see that some of these might not have any recycled or renewable content. So they are virgin materials, which have been new made, which of course from a circularity point of view isn't great. We can still improve that by having materials which are lower in emissions. But if these are lower in emissions, but they're still virgin materials, it won't improve our circularity score as well. But if we can perhaps recycle them, that could of course have quite an effect. So if we see that we have some materials here which are landfilled, which is not great, but it seems that we might actually be able to recycle the bitumen or these kind of things. So all the changes we have here are directly affecting the circularity score here. If we go to the result page for our concrete office building, let's see what kind of things we have. So we have here the 7,000 square meter office building, very high percent of virgin materials. And that is probably because most of our materials here, the concrete is virgin. We have quite a low percent of renewable or recycled. So the values we have there are just the ones which are coming from EPDs. When a manufacturer tells us, okay, we have used X amount of materials which were renewed. When we take a look at the returned materials, so what happens with our materials after the building is deconstructed, there's not that much being disposed of. So that's kind of okay. Probably materials which are inert, which we cannot really recycle, like perhaps insulations. We have only some which are recycled, but I haven't marked anything as reused. So that is of course something I could do myself, and I'll show you in a bit in our wooden design. We have a lot of concrete which is downcycled. Of course, if we build a concrete building, the majority of materials are going to be concrete. So concrete we can downcycle to aggregates. So there are some benefits to it. We can reuse it again, but it won't really be the same function anymore. We have some materials which can be reused as energy. So any type of organic materials we can incinerate, or perhaps plastic we can incinerate, that will of course be good. So if we add up those materials recovered and materials returned, we get to about 28% circularity, which I think might be give or take what we're at nowadays. Like it of course should be as high as possible, but circularity is definitely not taken into account in all the LCA assessments nowadays. If we take a look at the total materials we have sourced for this project, we have almost 9,500 tons. And most of it, not a big surprise, is of course the concrete. So we can see we have a lot of virgin concrete there. If we take a look at the materials returned, what happens with these materials? Most of our concrete is downcycled. And if we're then taking a look at our key material groups, so the biggest groups which have an effect on circularity, most of these materials are concrete, almost 8,000 tons of it, and 99% of it is virgin. So of course, if we're actually building this, we probably don't want to build with as much virgin concrete. And since the virgin concrete is kind of heavy in emissions, but it can be downcycled, we do have 50% materials returned, but that only leads to about a circularity percentage of 25%. Metals, however, can often be recycled really well. So the circularity point of view is quite high there. Bricks, technically, you could reuse reclaimed bricks because bricks can last pretty much indefinitely, but in this example, I haven't marked these as to be reused. And gypsum base will usually be landfilled. Insulation, depending on the type of insulation, but likely in these examples, it's landfilled. Glass will be recycled, but not to the same level as it was before. And then, of course, we have organic materials, which are by definition renewable. So the circularity point of view is quite high there. There are some other examples you can here also see if we have used, for example, the design for disassembly and adaptability, but I haven't covered those specifically here. So this is now the concrete design. So 28%, not too great. So if we are doing a wooden building, we probably should be able to improve on that, I would think. So if we have then here our wooden office building, we can already see from an environmental point of view, it's quite a lot lower in emissions. So if I want to actually view the results of this one, we're just looking at the emissions right now and compare it with my other one. So I will compare the designs. I'll compare it to my concrete building. I can see emission-wise, just global warming potential, it's already 37% lower. So that is quite good. The transport is also a lot lower. This is probably likely related to the fact that we just have less mass to transport because I actually haven't changed the transportation distances here. There's a little bit more A5 emissions. So we might have to have a bit more material waste because wood has to be cut in pieces, which you obviously don't have if you do precast concrete because it's already in nice ready-made assemblies. We have some more replacements. So organic materials might not last as long as precast concrete in this case, even though nowadays it can also last quite long with the right treatment. We have a bit lower end-of-life emissions, probably because we have less emissions for the treatment. And then we have more benefits in the D phase because organic materials can be incinerated, which of course leads to reclaimed energy. So and also in most of the other categories, we actually have improvements. So lower acidification, lower ozone depletion potential, and of course more biogenic carbon storage because we just have more organic materials. So if we then take a look at our wooden design, but we look at this from a circularity point of view, we could probably see right away already why the score is a bit higher, but we could probably try to improve it as well. So I'm opening my building materials query there. And we can see that the first parts, these are exactly the same between my other buildings. So I haven't really made any changes to the steel core piling or sandwich elements or these kind of things. But what if I use better concrete? Let's say we are using concrete, which is actually 30% recycled binders. So I can, of course, change these resources. But for this example, I will just change the percentage of recycled content. Because in this example, we don't look at emissions. We look from a circularity point of view. 30% recycled binders in theory does not dictate 30% recycled content. It would probably be, let's say, more like 4 or 5. But for just this purpose, I will just show this. If we are having other type of elements which are specific to this type of construction, which is timber or wood, I could open these ones and I can see that from the materials we have chosen here, we have quite a high percentage of renewables. So of course, any type of timber or wood or organic materials, they usually have quite high recycled content. So we can see completely renewable. We have some gypsum, which has some type of recycled content. We have some insulation panels with some type of recycled content. So these are not going to affect it too much, but these will affect the circularity score quite a lot. But what are we going to be doing with these elements afterwards? So if I scroll to the right and look at the end of life processes, we can see that, for example, the wood is currently marked to be incinerated. So then we have some benefits from it. We have here some, what was this? Plastic vapor control layer and glass wool, and these are landfilled and incinerated. But these kind of changes can affect, of course, also the circularity quite a lot. If we make some changes to ensure that the materials can be reused, from a circularity point of view, it's of course much better. So perhaps if I look up here and I'll look at my foundation, I could build this office building actually on top of an existing foundation. So perhaps the elements we have here are completely reused. If I'm doing that, it will of course change the circularity point of view quite a lot. So maybe I set this all to 0, because this was all, let's say, existing. I'm just marking them all to be reused. I won't change the bitumen sheets because probably they will not be able to be reused. But if I just make these changes, so now we're assuming that we have an office building, which is a timber frame. So that is already better from a circularity point of view, in which we're actually reusing the foundation parts. So I'm just waiting until it saves this. While we're waiting, Marina asked if it's possible if I use a different colored pointer in the next sessions. I probably can. I just haven't properly sorted out what kind of pointer I can use, but I'll look into that before the next session. So we can see because of the savings or the changes I've made, the circularity score actually increased by 6%. So that's great. When I just go back to the main page because I want to see the overview, that means that the circularity of that design should now be 38%. So now it's already quite a lot better. If I then navigate to the result page, so I just look at this from a circularity point of view, we can see that where in the first one, when we had the concrete frame, where we had about 9,000 tons of emission of materials, we have first of all quite a lot less materials. There's still a good number of virgin materials, but we have now 13.3% of materials which are actually reused. That is, of course, because I had assumed now we're building on like existing frame. So that right away boosts the circularity point of view, because this 13.3% is added in total to this one. So the virgin is still not counted. When we take a look at the other parts here, we have still nothing that really will be reused afterwards, but we have quite a lot which is reused as energy, and there's unfortunately a bit more disposed. So it's possible that we have more installations in this case, which we cannot really reuse. But still, just changing those two kind of things, including some materials which might have been reused beforehand and using more renewable materials, so organic-based wood, plant fibers, this kind of stuff, we have already increased the circularity score by 38%. And if we are then looking at our key material groups, there is still quite a lot of concrete, which is virgin, but we have some materials which were recovered, so the percentage isn't as high, and the circularity score for concrete has gone up from 25 to 33%. We still have metals which are quite a lot reused, and we also have organic materials, but we just have a larger quantity of this. So 308 tons versus 50-ish, I think it was in the previous one. So because we have used more organic materials and we have reused part of the frame, of like the concrete base of the frame, the circularity score is right away quite a lot lower. So these kind of optimizations you can do quite easy with Carbon Designer, but you can also do it, of course, completely manually. Like if you want to make these kind of changes yourself by changing the constructions to kind of like figure out what you want there, it is definitely also possible. Now I'll just switch back to my slides for a second, and then we'll talk a bit about some basics of the construction materials and then we'll go back into the software, and then I'll actually talk about these materials as well. Let's try to have a break in about 10 minutes, like a 5-minute break again. I think people really liked that the last time, so then we do that. Let me just share my PowerPoint again. Just making sure we get to the right slide. Give me 1 second. All right. So yeah, let's now talk about how you can find materials in our software. So those of you who have already used the software probably have already seen the filters. I assume those who have done the homework have already searched for the materials and kind of seen how you can find them in the software itself. But let's talk a bit more specific. So what kind of material groups do we have? How do you find these? And how can you also compare these with each other? Because that is, of course, also quite important. The best way to find data is, well, first of all, you can do the free search. But if you're not really sure what material you're looking for, or you're not sure how it's called, it's better to do it based on a material group or subgroup. In this example, I have the material filter open. And if you just type it or you click it open, it will right away give you an alphabetical list of all the material groups and then also the material subgroups. So we could see that this example, we have the asphalt group selected. If you click on the asphalt, it will basically go into 2 different groups, asphalt and asphalt binders and bitumens. So for all the different material groups we have there will always be subgroups to make sure that the data which you can compare with each other is kind of like comparable. So if we're doing different type of glass, I wouldn't want to compare normal glass versus safety glass, for example, or I wouldn't want to compare one strength grade of concrete with another strength grade of concrete because in theory, they are different products. The main material categories we are following are as follows. So we have the asphalt, which is relevant for, of course, infrastructure construction, but it's also very relevant if you're doing hard landscaping. So you're including pathways, roads to the building, perhaps, really relevant for the United Kingdom. And under asphalt, we have the asphalt and asphalt binders and bitumens. We then have the bricks category. And in our bricks category, we basically distinguish between the basic common clay bricks and then wall and floor tiles, my bad. We then have a separate category for cement binders and additives. And this includes just exactly that. So different types of cement like Portland cement and alternative concrete binders. There is a section on construction site operations, which doesn't have a lot of data. But for example, in the UK, they require that you also include excavation works there. So you can actually include them on the building material query with that specific query. And then we have our massive list of constructions. So the constructions, which I just showed earlier also a bit, those are all those ready-made ones, which you can use if you are not really sure what kind of materials go underneath them. So let's say we have a building, you know, you're going to have external walls, but you're not really sure what materials go under these external walls. You can just select the construction filter. You select, for example, the external walls filter, and it will tell you all this different type of resources which you can enter per square meter, and it automatically tells you how much materials are underneath them. So very useful. And if you're very new to construction materials in general, or construction in general, I definitely recommend to check that out. We then have our doors, windows, and partitioning systems. And this has quite a lot of subcategories because, of course, there's a lot of different type of door systems and window systems. So I'll show that again in a bit, but anything you're looking for, aluminum windows, wooden windows, steel window frames, different type of doors and whatnot, everything goes to that category. We then have the earth masses and stones, which is the category where basically all the natural materials are. So you would have sand there, you would have soil, gravel, any type of recycled soil and aggregate, natural stone, and recently we also added a category for engineered aggregates. So anything regarding that you find there. We then have the flooring, and the flooring can be quite tricky because there is a lot of different types of flooring. And if you're comparing a specific type of flooring, let's say we're doing 2 types of carpets, you really only should be comparing them between each other if you're looking, for example, at carpets. But we can compare also all different types of flooring. So we could compare a building with linoleum flooring versus carpet flooring versus a laminate flooring versus marble flooring. Like anything is really possible, of course. But everything regarding flooring and finishes, you can usually find there. We then have the different types of glass. And glass is, of course, very important because there aren't a lot of buildings which don't have glass. And these are gathered between our regular glass, so really the basic glass panes, safety glass, which is usually stronger, coated glass, which can have, for example, sun protection or similar. And then if there's any data related to glass facade and glazing, will also be having a separate category. Then we have our gypsum and plaster. And gypsum and plaster is basically anything that goes between internal or external wall, for example. We have gypsum boards, but there can also be gypsum plaster, leveling screeds for floors, mortar for bricks, tile adhesives, or different type of concrete admixtures. Then there is one section which kind of requires a bit more information, and that's the installations and systems, or as you would also say, mechanical electrical. This includes any type of installation, but it, for example, also includes the fittings of furnitures. And if you're traditionally looking at the whole overview of all the building materials, there will not be as many options there, because if let's say I'm a manufacturer who wants to sell some products. If I am selling concrete, it is much more likely that my client will ask me for an EPD for my concrete because they want to check what is better. But if I'm selling printers or whatnot, they're usually not going to ask me for an EPD for a printer. They might ask me for a cost image or something like this. So installations systems, anything related to heating, cooling, it is kind of upcoming, but the quality or the quantity of the amount of data points isn't as big yet there. We then have, of course, insulation. Any country where we don't want to be too warm or too cold, we are going to insulate our buildings. And there is a lot of different type of insulations. Some only work well for certain areas of the globe. Some installations you're not even allowed to use in certain areas for building. And insulation very much depends on what you try to achieve with this building. Usually also a very important part of energy modeling if it is considered there. Then, of course, on to two of the biggest groups of emissions are precast concrete and our ready mix concrete. The precast concrete category will have all types of precast elements which basically have been recorded for that element. So it could be one beam, one column, different type of wall elements, these kind of things. And then ready mix concrete, we usually talk about different strength class and different functions. It's also something Pando discussed in the last one. It's important that you take the right type of concrete which will actually meet your building requirements, of course. Then we have three more categories which are relevant in this category, and that is, of course, our steel and metals. So there are a lot of different types of steels we can take from, and we have gathered them based on their function or what they are most used for. So we have there the stainless steel, we have structural steel, two of the biggest groups of emissions there. And then we, of course, have the reinforcement steel. We cannot have a concrete building without reinforcements, so very important. And then there's a couple of other types of steel, like coated steel or sandwich panels, specific steel sealing systems. They all belong to that one. Then there is one category specifically for systems and assemblies. So kind of similar to our constructions, but then more from an EPD point of view. So EPDs for systems which are already ready-made. So a manufacturer might have a thermal system ready or sandwich panels, which basically consist of more than one material, but they are covered by one EPD. So in that case, you could have an EPD for 1 square meter of sandwich panel, which already includes the steel, the insulation, any other type of materials, which basically go there. We then have a category for wood or timber, or however you want to talk about it. And it has all the different types of category of wood. So we have the plain wood and timber, so your normal soft and hardwood. We have CLT elements, glulam, LVL, treated or coated wood, plywood, fiberboard, particle board, oriented strand board, and if there's any specific type of insulated wood elements, you can find them there also. What is also kind of important to point out, and which is also why it's very useful to have this kind of categorization system for the materials, is that the materials might be named different around the globe. Like if we take the example of wood, one part of the world we might call it wood, one part of the wood we might call it timber or lumber. And if you're not really familiar with how different terminology is used around the world, it can be quite tricky to find these kind of things. So if you're looking for data, you cannot really find the right material based on the search term you're looking for, just try to find, first of all, with the categories. So select the material class and the subclass and try to find what kind of rolls out of there. And usually you will already be pointed in the right direction, because even though the names of how I call wood in Finland or in the US or in Australia might be different, the materials is usually quite similar, so you can find them quite easily. So then for the next part, I will discuss a bit more about different features. So we have our advanced material comparison, we have our green materials benchmark, and then I'll show these also in the software. But let's see what time it is. Let's actually have a 5-minute break right now, and then we'll come back and I'll discuss a bit more about these building materials. So I will be right back. All righty. I hope everybody has had time to get some coffee and some water or whatnot. So then let's continue if I can get my presentation to work. And unfortunately, it goes to the wrong slide again. Okay, let's skip through these. So before I will show you how we can actually look into these features in the software, let's just shortly discuss them. So in order to find or perhaps compare, try to find the best resource of all the resources, we have two very useful features. And these were kind of shortly covered during the session 3, but I'll go into a bit more in depth now. And these features are our advanced material comparison and our green materials benchmark. The advanced material comparison feature, you can also see the link right here if you're on our help center. It allows you to kind of do quick impromptu analysis of, let's say, 2, 3, 4 materials without having to do an entire study. So it's kind of a feature in the tool itself, which opens kind of a new screen. And it allows you to really quickly see the difference between certain materials, either from an emission point of view or a cost and carbon point of view. How we access this feature is if you have the building material query, which I, in this example, have opened to the glass wool installation group. If you search for some data, you'll have the checkboxes here. So you just check some of these boxes of data you want to compare. So you could do, for example, just local data, or you could even compare data from different countries. You click them to the Add to Compare button, which opens the Compare Data function up there. And the Compare Data function will be right about here in the top right corner if you're doing this type of analysis. It will then right away show you an overview of the life cycle impacts. We can also see the cost and carbon data, and we can see the full data. So for this example, I had selected 6 glass wools. I think these were mostly from Finland, but there might be one from Norway. So we could see right away that between the different ones, the glass wool we had here from Isovar was actually quite a lot lower than the rest. But from this, we could already maybe decide, okay, we don't want to go with certain type of glass wools we had picked here earlier. So this is quite a useful feature. It's available for pretty much all the materials you have. Just if you do this type of comparisons for the installations and systems, there it might be a bit more tricky because those materials are not as comparable as, for example, different type of insulation or steels or anything like this. We have also the green materials benchmark feature. And again, if you're on the help center, just type the green materials benchmark. And this allows you to actually access the entire data set for one specific material subtype. In this case, we could say we have the glass wool, which I had there. The glass wool then will have, let's say, 1,000 data sets. And of course, we have some good performing glass wools and we have some bad performing glass wools. We can access this specific data set in a couple different ways. If we are searching for the material names, we can already see the little carbon cloud symbols, which I'll show you in a sec. We can also use our CO2 equivalent filter, which allows you to narrate different type of quintiles of this benchmark group. And we can actually access the green materials benchmark in the data card itself. So we can see it there as well. Theo asked, be careful for the functional unit unless it's accounted for in the comparison tool. It is indeed accounted for already. So data usually is recorded according to certain functional units. But if we, for example, have the group for glass wool, the comparison is done on, for example, a cubic meter, even though they might be recorded with different densities and whatnot. So if we're searching for this glass wool and we see those little carbon clouds there, we can already see where they are in the quintile of that performance group. If we have these 4 generic glass wools, we can see that one of them is in the top 40%, one of them is in the top 60%, and then we have a couple which are in the 80%. So the darker the cloud, the worse performance-wise it is compared to other data in that specific benchmark groups. It is also possible that you find a resource which might have a warning because either the emissions are so low or so high that they are not that comparable. In that case, the warning will also display it with a little triangle beneath it. If we have that CO2 filter, so if we're on the building materials query, we can also search through that benchmark set. If I would set this one to very low, I only get the top 20 best performing resources of that performance group. So maybe I don't want to search through thousands of glass wools. I only want to see what is the best available to me right now. I set it to very low and it eliminates everything else. So it's a very quick way of searching for this data. If we open any type of resource on the building materials query, like I have opened a generic glass wool here, I can also see always under the environmental profile, I can see the performance ranking. So for this benchmark, I can see that in the performance ranking for glass wool, we have 983 resources. So these are all generics or EPDs which we can use. This one is number 454. So there are actually 453 which are better performing than this resource. This type of benchmark group is available for pretty much all, but as I said, with the MEP or the installations and systems, there it can be a bit tricky because there you have a lot of variety in different type of resource you're comparing with each other. The glass wool benchmark example which I had, let's elaborate on it a bit more. So if I open the glass wool group, I saw earlier already in my previous slide, I'm not sure if I can go back yet, that there are 983 which are eligible for benchmarking. In the benchmark group itself, there's actually a bit more, 1,014. But there are some resources which are, for example, so high in emissions that you cannot really compare them with each other. So we leave those out of the benchmark group. What I could do right away here is perhaps eliminate quintiles right away. If I'm seeing the resource I had selected, it's at 28.17 kilograms of CO2 equivalent per cubic meter. It is not on the lowest benchmark group, but it's definitely also not on the highest. So there's a lot which is performing much worse. If I would select or unselect the very high and the high, it eliminates right away 40% of those, which basically gives me whatever I have left underneath here. So if I'm looking for a good glass wool in Finland, I could say, okay, in Finland, we have 71 projects or 71 products which could meet my criteria. If I want to go a bit better, I could say I'll take 40 kilograms of CO2 equivalent per cubic meter as my benchmark. I only want to see data which is underneath that. If I click that one, it will tell me, first of all, that there are still a lot of resources behind my benchmark. So 665 possible resources from all around the world. I can see that behind my benchmark group in Finland, there's only 36, which could meet my requirements at this point. If I'm looking at neighboring countries, so for Finland, this could be, for example, Norway, Sweden, Russia, we have 29 still below the benchmark. But if I look worldwide, we can see that there's quite a lot of options. But if I'm building locally, I probably don't want to get my installation from Canada or Spain or whatnot. So let's try to just go for good products. I want to do something really sustainable, so I'll select 50% under my benchmark. So then we have quite good performance. Then we just get left with 10. And in this case, I could see that there is a specific glass wool from Isover, a specific standard 42 roll, probably some product name. This would be my best bet. So if I would want to go for the absolute best performing environmentally, I could go for this one. So even though this specific glass wool might have been recorded in a different thickness from others, because we calculated to one common functional unit, in this case, cubic meters, we can still compare it quite well with each other. And of course, the functional unit we have here is not the same in all material groups. Like in some, it might be kilograms, some it might be tons. So depends kind of on the material we're looking for. But yeah, it's quite easy way to find it this way. I'll go over also that in a bit in the software itself, but let's quickly also talk about the results, and then I'll cover that in the software itself. When we are looking at the results of anything we're trying to do, we can basically get it in two pages or two places. We can get it from our main page when we have done some quick analysis and we just want to get the totals, or we want to compare some type of graphs, or we can actually get it from the result page if we really want to dive a bit deeper into what we are doing or analyze which building elements are causing most emissions, which materials are the heaviest, and these kind of things. So the main page is always the quick way. You just get the overview, you get the total, you get some nice comparisons, or we do it a bit more advanced way on the result page. When we're on the main page, and this is if you just open the project itself, it will always start on the top with the results and benchmarking. So depending on what we have done, it will show us the Carbon Heroes benchmark, which is our own internal benchmark program, which you can select your building, or you can benchmark your building against other sets in the benchmark group. We always have the embodied carbon by life cycle stage. So just the total overview we have here doesn't include operational carbon. And then we have it by structure, so percentually. If you have the slides, you can also click on this article, which takes you to the article for the embodied carbon benchmarks, if you want to perhaps read a bit more about that. I see there's one question about DEMA. Can you put that in the Q&A part? Like my colleagues will get back to you then, or I will do it after the session. After that part, we have the design phase. So if you have already used the software, this will be very familiar to you. And here we always have the functional unit of the entire calculation. So this could be kilograms CO2 equivalent for the entire assessment. In some other tools, it might be per square meter per year, kind of depends on the certification you're pursuing. And then we have the total score. So we could see that for this design, the office building, we have 2.3 ton or 2.3 million kilograms CO2 equivalent and a circularity score of 28% for that specific design. These usually also only include data depending on the scope of what you're looking for. So if you would have two completely different tools with each other, maybe one which also includes energy, the functional unit might be the same, but the total score might be different there. So that very much depends on what type of assessment we're trying to do here. The results figures you see here, they only populate when the mandatory data is met. So that basically means that for the design I have here, which it still says that input data is red, I'm missing some type of data. Could be that I haven't entered the building area or a calculation period, or maybe I haven't entered the energy or something. But if you don't get a number to show up here, it's always because there's something missing. You can usually just click on the input data and it will tell you exactly what it's missing. You populate that and we get results on the main page. So it's quite straightforward. What we also have on the main page below the results is graphs. And these type of graphs we can use for all different type of comparisons from a graphical point of view. We could, for example, set it to the life cycle stages. And in this example, I just have one, but I'll show you in a bit where we can compare them with each other, as I did earlier also. We can also select different type of designs we want to do. So if we have multiple designs with different building options, we could compare them with each other quite nicely. I can also change the tool and impact category. So if I would want to change it to acidification instead of global warming potential, I could change that quite quickly there. I could also remove some of these elements. So if I would click here on the B4, B5, or the B6, it just removes it from this graph. And under this little icon here, we can always also download them. So let's say I want to download them as image format or as Excel, or I want to get the data table to use it in my own software to make some graphs. It's always possible as well. The result page, it can only be accessed by going to the result page. So if we're on our main page, before we're doing anything else, you open your project, you can click on the score, even when it says input data that something is still missing, you can always navigate to the result page. So even if you don't have all the results, it will still generate results, just not on the main page. If we're on our result page itself, on the top right top there, we have, first of all, the compare designs option. We can compare designs with each other if you have designs which have data. So that basically means if we have done two options, a steel building and a concrete building, they both have data that makes them comparable. You can do this comparison and you can automatically see which one is better from performance point of view. On the top right, most top right, we also have the more actions option, and that allows you to actually either generate reports, Excel or Word report, or actually send the data to other users if you're perhaps cooperating with other colleagues on this. This usually gives you just a base overview of all the raw data in your project, at least if we do the Excel report. And the Excel reports are always as specified for the certification. So an Excel report for levels or Excel report for LEED or BREEAM, they will all be kind of different because the format of the data has to be different. In the case of BREEAM, the data which you get from Excel has to be readable in certain BRE tools. So we cannot have the data in a different format because then it cannot be used for certification purposes anymore. And for that reason, also, most of the tools we use for certifications are pre-verified by, for example, the BRE. What we can also do is if we are on the result page, we can analyze the details of the assessment a bit more. So if you have the total results on the top right, you always have a list with all the details. If you click on the details, it will open something similar to this. So it will tell us we have this concrete office building. We can see that 19.53% of the emissions are from our foundations. Great to already kind of narrow down where the issues might lie emission-wise, but we can also narrow that down even further. So we can actually open, for example, the foundations and see exactly what is causing most emissions in those. We can undo it based on percentage or absolute values, so emission values. In this example, I have set it actually to the emission values. So we can see in the foundation exactly what is there. And we can also see how the software calculates it if we would want to check that. Then we have the results page, the completeness and plausibility checker. So this is a checker I've also shortly discussed in session 3, if you remember, which kind of checks the plausibility of your results and the completeness if you have set a certain scope. So the completeness is not shown here, but the plausibility checker is. So in this case, it checks if my project, what size it is. So you can see 6,612 meters of gross internal floor area, concrete frame, and it has certain elements there. So the foundations, the substructure, etc. Based on that, it does certain checks. So it checks, okay, the structure mass is credible. We my bad. We have enough materials for the finishes to be significant, etc., etc. So all these checks it does based on existing validated projects in our software. So if you have a project which has a correct set building size, you have all the materials you think should be relevant, it can usually give you quite a good indication of what should be there. For this example, as I have made this with Carbon Designer, it has pretty much all the materials it should have. So we can see that the LCA checker grade is actually A, which is the highest grade you can get. It does have some checks here that it says are perhaps not credible. The first one here, the services, is because I have included it in the scope, but I haven't actually included materials for the services. So I haven't added elevators, heating and cooling systems or anything like this. External masses, I haven't included any landscaping, so I haven't added any roadways or these kind of things. And the foundation is probably because I have made some changes to it, but it's kind of still in the acceptable range. So these kind of things can be quite useful if you're doing your first LCA. You're not really sure where you might want to look to make sure that you have everything. So this is always available in the building materials query and on the result page. So quite useful tool. On the result page itself, and this links back to our advanced materials comparison and also the green materials benchmark, is the top 25 most contributing materials. We can see from this right away what the material is about. I can also click on the question mark and find a bit more information about it. I can also see the cradle to gate impacts, so the A1 to A3, most important in this case, and what the total is to the entire project. So based on this, I can already see this ready mix concrete. It has a light green cloud, so it's in the top 40%. Could probably find something better for that, but we have some ready mix concretes here. They might be a little bit different ones because I actually haven't opened them, but they are in the top 60%. So they could be replaced by even more better concretes. I can also click on the show sustainable alternatives, which basically gives me an overview of all the better options which would be available to me in the database, which are relevant to my project location. And if I would actually want to do some extra comparison, you can do it as well. Dima asks why the DGMB tool cannot do localization. It's not allowed. In DGMB, we're not allowed to use localization. You have to use only original data, pretty much. If you click on the green materials benchmark feature, it will also take you to the article itself. Then, of course, we have a lot of different type of graphs. So I'm not going to explain all these graphs because they're mostly used for like showing your clients or whatnot, or kind of making a point from an analysis point of view, but there's a lot of them. So the more graphs, the better you can show to whoever you're trying to show why you should reduce emissions. There are the basic charts, first of all, the pie charts, the bar chart, the column, and the tree maps. And then there's a variety of other charts there. By default, it, of course, highlights the global warming potential, because that's the main thing we're trying to reduce. But you can always change the impact category and also perhaps select acidification or ozone depletion potential or anything like this. And with all the charts in our software, you can always download them either in Excel or CSV or image format if you want to use them in any other type of ways. Lastly, we have then that list of all the data sources, which will be under your graphs, which you could use as, for example, proof that you have used X data or something like this. So that is always available there as well. Then I will shortly still show some stuff in the software for about 5 minutes, and then I'll answer the Q&A stuff. I can already see that there's quite a lot of data which was answered by my moderator, so thank you very much for that. So let's go into the design I have here, which is our building materials query. So the filter setting, which I talked about earlier with those materials, you can always find there. So there are, of course, a variety of other filters you could use, but if you're just looking for the right material, the material filter is by far the easiest and quickest to use because it narrows them into those different groups. The one thing that I kind of want to highlight here is if you're doing the installations and systems, be a bit careful about comparing data there because you can have similar equipment of very different sizes. So when we have our insulation, our steel, our concrete, this is always kind of, you can narrow it down to one functional unit, like a cubic meter of concrete, square meter of insulation. But in installation systems, you often have resources which are recorded in unit. So you might have a generator of 5,600 kilograms or something like this, which you are then comparing with a generator of 300 kilograms or something like this. So be a bit careful there. But otherwise, this is quite nice way to search for the data. Then the advanced materials comparison. If we are opening any setting, maybe I would open my gypsum and I'll set this to regular gypsum board. If I open it, it automatically tells me what type of data is meeting this specific material requirement. So I could then say, I want to compare this local gypsum board versus this generic gypsum board versus this gypsum board from Norway. And maybe I want to put a Swedish gypsum board there. I can then add this to compare. It will tell me it has done so. Then I can go to my compare data. And it still also has some glass wool insulation from earlier, but I'll just get rid of that. And then I can automatically compare these with each other. So based on those data, which I just had, I can see which one is lowest in emissions. It's definitely this generic one that I have here, but we have some different ones from different manufacturers, which I could also compare with each other. I can also do it based on cost and carbon. It seems that for my generic one, I might be missing some data to compare this nicely with each other. So this comparison feature can be really good if you don't have time to do a full analysis or sensitivity analysis or whatnot. You just enter what materials you want to compare, and you can compare them quite quickly with each other. So I'll just close this one. Then the advanced material benchmarks. How do we access this? So I have already gone over this in a bit, but let's look at it again. And let's take a different resource. Let's take some carpet flooring. So if I open the carpet flooring, I will now only get resources which are belonging to this performance group. So there were a bit over 500 there, 516. So I can right away see which ones are the best. So we have, based on the carbon clouds, how they are performing. So I could say, maybe I'll take a Dutch one from the Inside database. I'll open the data card itself, and I'll narrow this down to the environmental profile. On this one, I can see we have the carpet, 516 resources in this performance group. I can then click on the see full ranking and see all the carpets in this group. Now, maybe I'm trying to find the best resource for Finland. I'm trying to find Actually, that's not going to happen because there's apparently no carpets made in Finland, at least none with an EPD, so that's unfortunate. I will still try to find some better performing ones. So in the neighboring countries, there's actually still not so much I could use, but then I just have to try to go for worldwide. Maybe I'm importing my carpet. If I'm using this based on the median benchmark, there's still one product which I kind of can use from my neighboring countries. It's a European generic one. Maybe I don't want to use that. Maybe I just want to find the best products worldwide. So I'll open this one. And then we see that there is one which is probably a completely recycled one because the emissions are way too low. But then if I want to go for something realistic, I have some options here. So I could maybe say this Interface Europe, which is making some carpet in, what is it, Ireland. This could be a good match for what I'm looking for, perhaps. Of course, it depends on much more things, but if we're just looking from an environmental point of view, you can use this type of benchmark really nicely to narrow down exactly what type of resource you're looking for. This does also kind of show right away that there is some issue which some countries have. If you're looking for local data, there is not always local data available for your country. It's not as much of a problem in Europe, but definitely if you're outside of Europe, specifically, for example, Asia, in those cases, you of course have to go for the best match you can find according to your material specifications. Alrighty, then let's go more into the results. So we have discussed a different type of results. Let's just go over them again so you can see them in action. And then I can answer some questions. So I'll again start just with the result page or the main page, my bad. So if we just narrow down all of this, we basically have three categories. We have our results in benchmarking, where we can compare the data we have versus other benchmark groups. So perhaps I want to compare this versus UK office with 81 projects. It looks quite okay. But if we're comparing this office to Finland, which has 46 projects, it's actually performing worse. So depending on where you're comparing your data against, it might look different in benchmark sense. We have, of course, then the embodied carbon graphs we can see right here. And underneath then we go to the design phase. So the design phase, as I said, it always shows the total picture depending on what we're trying to assess. So this could be the total emissions for the entire project or the total circularity score, anything like this. We then have the different type of graphs for comparison. So if I would want to perhaps exclude this one, and maybe I want to set it to global warming potential for the levels tool, I could right away compare all the data I have just from this. And this I could, of course, also use for different type of graphs. Maybe I exclude this one again. And then I could, for example, download these or view them as data table to get the total overview. So quite good if you're trying to do some quick optimization and you want to just see from right away what is better or what I can compare, just like this. Perushard asks if these optimizations can be simultaneously also compared with costing and other one-click LCA licenses. Yeah, of course. If you have a lifecycle costing tool, you can just select it here and select that one, and it will display the costs. So it just depends on what tools you have in your project at that moment. In this one, we just have some basic tools. So then we have some more result stuff. So I go to the result page. So you can always edit it here. Also, if you don't have all the results yet. So, okay, this design actually doesn't have any results, but if I would only have some building materials or some energy, I could still view the results. So I would open this one maybe. Tara asks if I can show the Sankey diagram. I'll show it, yeah. So this is the basic result page. So we have, first of all, the total tons of emissions, the emissions per square meter per year, and then also the social cost of carbon. We again can see the benchmark set. And above here, we can also do the comparisons. We can download the reports right here if we would want to. And then we can go further into the results by, for example, clicking on the details tab. So if I would want to find out what is most causing my global warming potential here, I'll just open this one. I get the total overview in percentages. So now I can see that my horizontal structure is actually causing 33% of my global warming potential. if I open it, I can see that of these, well, probably the highest is actually the ready-mix concrete I have here. But if I would want to see how the software calculates it, I could also set this to numbers and actually see right away how these calculations are made. So we can see quite a lot by really narrowing down perhaps the building element on the individual materials to what we're really trying to look at here. I can, of course, also narrow these down and expand them if I would want to look at different type of sections there as well. Then we have, of course, a bunch of other indicators which are relevant for levels. Then we have there the completeness and plausibility checker. So the first one, the completeness checker, depends on the scope we have set. So for this specific design, I haven't really set a scope for levels. So what it's checking there, the 7%, is probably not really that accurate. But the plausibility checker is, of course, more accurate. So here it checks the type of data I have to see if it's credible. I can see here that these two checks, number 2 or number 3 and 4, they are marked as wrong because I have a different setting in this design. So I have here a whole building with a concrete frame type. I happen to know that for this design, I have a wooden frame type. So it's checking now concrete against wooden, which of course won't work. If I would change the setting to actually allow for a wooden frame, it will probably validate these checks. But it has all these kind of checks, which it looks at either in expected quantities of materials per square meter or expected emission values per square meter, percentage of materials, number of items, all these kind of different checks. So quite useful if you're doing your first LCA, you just want to check, okay, what do I have here? Or even not if you're doing your first LCA. If you're just doing an LCA, you don't have all the data. You can easily see, okay, we might be missing this or we might be missing that. I might want to focus on the windows. I might want to focus on the rebar, anything like this. The most contributing materials can, of course, be quite good to help you find better options. So we have here the structural steel. I could see that performance-wise, this one is number 156 out of 299. I can probably find a better option. Then what I could do is show sustainable alternatives. And it tells me that there is some welded steel tubes. Maybe that won't fit that well, but how about this one? Some steel beams from Norway. They maybe could work. So depending on what I'm trying to look for, I can quite easily find better options. And the resources which it shows here are, of course, relevant for the country that I'm in at that moment. Like if I'm searching for Finland, it's not going to show me steel from Thailand or something like this. So if you have a different location, you'll probably get different materials showing up here. Then we have the different type of graphs. So let's go over them as some people were interested in this. So we have the pie charts, the bar charts, the columns, and the tree maps. So all of them kind of in this one show the different life cycle stages, the resource types, the classifications for the mass and the classifications for global warming potential. Then we have the bubble charts, and it shows the biggest groups of material emissions in our project. Not even material emissions, it can show anything really. And you can also exclude parts if you don't want to compare them. We have the Sankey diagram, which shows the flow of emissions throughout my project. And you can also configure this a bit different to, for example, include the resource subtypes. So we really can get some nice graphs which show all the flows of materials through the different building elements, to the different material types and where they go. We have then some more tree maps which specifically talk about the resource subtype and the life cycle subtype. Then we have life cycle stages, obviously. One graph that always has to be there, which shows the different type of emissions for the different life cycle stages. We then have annual emissions. Annual emissions, if you don't include energy or water, might kind of look like this. But of course, if you have energy and water, there could be much more here also. Usually you see that the A1 to A3 is the largest there. We then have the spidergram, which shows it based on classification system in this case. So we have now the building parts breakdown, which is levels, so it shows that one. We have the stacked life cycle stages as columns. So we can see for the different type of indicators where the majority of our emissions is coming from. We then have the materials stacked. So for the different emissions, so we can see in global warming potential, very large part is coming from the structural steel, but also the woven wall-to-wall carpet is actually causing a lot of emissions. So depending on what we have, can be quite nice to understand the different type of materials you have there. If you have assigned the correct classifications, you can also do it based on classifications. In the levels tool, of course, we take the building parts classification because this is what we are using for levels. But in Braham, this could be using the Meta 1. In LEED, it could use Omni class. It kind of depends on what we're trying to do. These graphs, you can also have all of them listed beneath each other if you really want to go all out and include all of them in your assessments. So yeah, those were the kind of things that I wanted to discuss during this session. So now I can focus a bit more on answering some questions. I'll just put the Q&A part back on if I can get to my PowerPoint. So I'll go all the way here. Questions. Alrighty. I see that there have already 60 questions been answered. So thank you very much to my moderators. That is great. Let's see if we can answer a couple more still. I'll just start from the top. Suganya is asking, I'm trying to include a foundation type, random rubble stone masonry with building cement mortar. The natural granite stones random sizes used in construction are locally sourced. So the best way to include that would be to create a group yourself. So you have this feature called grouping materials as constructions, which is available to you. So you would probably have to calculate what type of materials or the constituents of your foundation type go into 1 square meter, include that, and then just fill it in for your group. Maybe I could actually just highlight the relevant article we have on the support center for that, which would be grouping materials as constructions. This one. So I would check this article for that. You can pretty much do what you're asking for with that. Other Brian is asking, where can I get the approximation number for seismic input sections for building parameters? So in this case, not sure if we can share the calculations behind it, but they have been done based on seismic activity and they affect the structural parts of Carbon Designer. If you have some more specific questions about the seismic input, I would recommend to just mail us on support@OneClickLCA and I can answer your question probably better there, because seismic input can be quite a long discussion, which I don't have too much time to answer today, unfortunately. Bram is asking, when changing column materials from steel to wood, are the amount of material corrected for the load they have to bear based on the other components? So if you change everything from steel to wood, then yes. But if you would only change the column and you don't change the beams, for example, it does not automatically see that you have just changed the columns to wood. Like you would have to change more. We're actually launching a new iteration of Carbon Designer after the summer, which will be more accurate from a structural point of view, but I'm not sure if it would consider this specific scenario. So you can, of course, do these changes quite good, but it's early phase baseline tool. It's not a structural simulator. So Rosanna asks, are the main questions in the exam requiring calculation for the program, or are they conceptual questions about material performance and construction type to mitigate energy-related emissions from building construction? Basically, if you have used the software and you have attended the session, you should be able to answer all of them. So you don't actually have to do calculations. So the questions itself, they will all be multiple choice because we're having a lot of students taking this exam. So it's not really possible to make an overly complicated exam, I would say. Hope that answers the question. Fishalaxi, I hope I pronounced it correct, my bad. Does the analysis compare to an existing case, which is ideal, so we know how we can optimize our building to a certain degree, kind of like a benchmark we need to read? So how you would normally set a baseline building is that you would have materials and construction methods which are typical to your building in your geographical location. So if I'm doing an office in Finland, probably it would be a precast concrete office which uses certain construction methods. If I would want to improve on that, I have to go look for alternative, better construction methods with better materials. So existing case, what is a valid baseline building in one region of the world might be completely different in another. So there's not like one type we can say, okay, it's always this one. If you have a benchmark, you should just try to improve it as much as possible. That's pretty much it. In LEED, you would have to now, for example, to get certain credits, you have to reduce by, let's say, 10% or 20%, or depending on what you're trying to do. Deidre asks, how can it be shown that an existing foundation can be built on? No engineer that would stand over it. I mean, that's a question you cannot really maybe answer directly from an LCA point of view, but if the existing construction or the foundation of a building is strong enough, you could build on top of it again. From an LCA point of view, that means you could save the emissions of not having to put new foundation in. From like, if it's structurally sound, it's of course a completely different question, which you cannot really answer through an LCA, unfortunately. An anonymous attendee asks, isn't excavation works the same as earth and masses? Earth and masses, as in a material category, are materials you would have to, or you are sourcing for your project. So it could be that you're using them in the foundation or something like this. Excavation works in this case really talks about excavated earth. So mass you're removing, but you're not necessarily reusing anywhere. And usually excavation in this case is counted for in fuel used by machinery. Sometimes it's also in mass removed, but usually it's diesel fuel used by machinery. One energy factor is asking, how convenient is it to use a specific material to improve a project? Is the best if the best material is manufactured in another location, and it implies transportation? It depends. If you have materials which are of good quality and are locally produced, but are higher in emissions, but you can get kind of the same material, but it's produced in a country where perhaps there's more renewables, it might be, from an environmental point of view, better to import it. So that very much depends on how it's produced, what the method of production is. Like rule of thumb, it's better to source locally. Locally usually is lower in emissions, but there have been plenty of cases where they have imported, for example, steel from other countries because it might not be produced locally, or in the end, it's still lower in emissions. So it depends a lot about where your project is located. Suganya asks, can we input the kind of appliances we will be using for heating, cooling, and lighting, and so on? You can indeed. So those are all available under the installations and systems query, but the amount of data or the quantity of data available there isn't as big as with traditional building materials, because there is not really a push for manufacturers to release type of data for heating and cooling and whatnot. So if we have the installation and systems, you would go to, for example, the HVAC components, as I'm now showing here, you will have quite a lot of different type of data which you could be using, but they might not meet your exact requirements. So you might have to apply some scaling or choosing the most the closest matches. We actually also have an article on that on the Help Center. I'll just pick it up now. So if you want to include building technology or MEP, I would recommend to check this article. It's quite good, straightforward on how to do it. Another question from Zuganya. Are there impacts on the choice of design, climate responsive design, passive regeneration, etc.? Can it be accounted as well? You cannot maybe include the construction methods, but you can definitely include the materials needed for it. Like a passive house might be higher in emissions, A1 to A3, but it might be lower in operational emissions because you're not having any energy use. So you can definitely include it. If you're using very exotic type of materials, like if you're building with some materials which are not that common, you might not find the exact resources in the database, but you can usually make them up from existing raw materials or materials which already are in the database. So then you can use that grouping materials as construction option. An anonymous attendee is asking, as a result of the LCA work, we are providing some alternatives to the structural engineer so he can fix some. I'm not sure if that's a question or just statement. I mean, you can, of course, discuss the LCA with the structural engineer and point out points which are like high in emissions, which you might want to change, and they can come up with better options. If you kind of mean that. Theo Meslin asked, hi, I checked the comparison tool in the program, and it seems to me that the result it shows is in terms of kilograms CO2 equivalent per functional unit. Is there any way to change it so it compares with the same functional unit? So we always, if you're comparing the same type of materials, you should compare them with the same functional unit. So if we're having that example of the glass wool is usually, or any insulation is usually recorded per square meter with a certain thickness. So one might be 1 square meter with 300 millimeters and one with 200 millimeters, which then correlate to certain heating properties or insulation properties. We try to calculate them so that they can always be compared with each other. So based on the density and the material thicknesses, we can calculate it to cubic meter. So then we set it, for example, to cubic meter so that you can actually compare them with each other without having to do hours and hours of manual calculations. So it should always put it to the same function unit, but what it's recorded in the EPDs, that of course might be different. But if you're trying to compare 10 glass wools and they all have different thicknesses and whatnot and different insulating properties, I would not really want to compare them that way. It's a lot of work. Rosanna asks, after taking the course, what is the average time one takes practicing to earning ability with commands in this software? I mean, if we are having a client which is onboarded, we train them in 1.5 hours on the basics of the software, which pretty much gives you all the information you have to know about how to use the software and how to do the calculations. You can take more time, of course, but when talking about how to do LCA, the best way is just basically do it. Like, we have a very competent support team who will answer any questions you throw at us, be it about the software, about the data, about the certifications. Yeah. Tatiana asked, if I use a Revit model, this last classification graph takes into account my original classification system. The building parts, not necessarily, but you can have different type of classification systems you use. Revit classification is basically doing it based on the building elements. So there are graphs which do the building elements, but it's not specific to Revit. It's basically any type of BIM modeling software which uses these type of elements. So based on if it's foundation or whatnot, you can see it in the graphs. Tatiana also asked, adding a parameter for the EPD number in the family type didn't automatically assign any information running the add-in, neither did it in the cloud. How do I know it was assigned or what have I done wrong? Well, Revit definitely has an option for including an EPD number, but I cannot tell you right now where you would put it in. Tomorrow in the session with Marios, where he will dive deeper into Revit and different type of integrations, if you ask him, I am sure he can show you. There was one thing in the chat, but I think T already answered this about a question about comparing different type of insulation. It would be great if there was an option to compare them based on insulation like U or R value. It would be, but manufacturers don't always provide this type of data in the resource. If it is available, we usually put it in the resource name. Maria asked if we can have these sessions a bit slower. I can try, but there's quite a lot of information I'm trying to teach everybody. So I hope you get it all on time. You can of course watch the recordings quite a long time still. They're all on the resource hub. So now this recording of course is not there yet, but tomorrow it will be. So if you're on the summer school hub, these slides and the recordings will be placed here every day. So you're always free to look at that later. Are there any last questions still? I think we have already answered everything, but there's something I can still punch out some answers. If there is no more further questions for today, then thank you very much for joining this sixth session on the One-Click LCA Summer School. Tomorrow we'll have the session on integration. So if you're interested in looking in any type of way of automating your data import from whatever BIM software or cost data you use towards One-Click LCA, definitely join tomorrow. I will be a panelist tomorrow in the session, but I will be with you guys on Wednesday already when we talk about certification specific things. And on Wednesday, I'll also present some information about the exam, how it's going to happen. And there have been quite a lot of questions about that. So thank you very much for joining, and I wish you all still very good rest of the day. Bye-bye.